In this session, we'll go with acetaldehyde and other aldehydes preparations. Okay, now preparations of aldehydes. In last class, we were discussing about the introduction part of aldehydes and ketones. Now we'll go with aldehydes preparations. Only aldehydes preparations we'll see. Next, we'll go with the ketones preparations. In aldehydes, you can prepare first from alcohols. And you have to take your primary alcohol. 1 degree alcohol on mild oxidation gives aldehyde. You can see here CH3CH2OH, it's a primary alcohol converted to CH3CHO. यहाँ से एक हाइड्रोजन, यहाँ से एक हाइड्रोजन निकाल देंगे हम. Okay, now we remove one hydrogen from here, one hydrogen from here. So you can say this is mild oxidation. We have to go with mild oxidation only. If you are going for the strong oxidation, then that will go for acids. If you are going more oxidation, this leads to acids. So mandatory condition, mild oxidation. For mild oxidation purpose, what reagents we can use? PCC is pyridinium chlorochromate, and PDC is pyridinium dichromate. Along with this, we can use chlorine or bromine or iodine. You can use any of these is okay. Or Fenton's reagent is fine. FeSO4H2O2. This is called Fenton's reagent. Or Jones reagent, Collins reagent, all these also we can use. Okay, now PCC, pyridinium chlorochromate, PDC, pyridinium dichromate, chlorine or bromine or iodine, FeSO4, H2O2. This combination is called Fenton's reagent. It's mild oxidation. Remember, this must be mild oxidation. Then coming to dehydrogenation. This is also looks like oxidation only because we are removing hydrogen. That you can do in the presence of copper or silver in at 300 degrees Celsius. Primary alcohols converted to aldehydes. Secondary alcohols will be giving you ketones, and tertiary alcohols will be giving you here alkenes. This is very interesting. CH3, OH and CH3. This is a tertiary alcohol. If you take this one, you will be getting here CH3. Alkene is formed. Primary to aldehydes, secondary to ketones, and tertiary to alkene. This is very special. We are using copper or silver. ये mild oxidation में नहीं होता है. You cannot use PCC or PDC for this reaction. That's why it is important. Then coming to dry distillation. Dry distillation में very interesting part होता है. One है HCOO taken twice. इसको आप अगर हीट करेंगे तो you will be getting HCH, formaldehyde. But if you are using a mixture of calcium acetate and calcium formate, this is calcium formate. Looks like same na? Calcium formate. Calcium formate on heating gives formaldehyde. But if you are using a mixture of calcium formate and calcium acetate, you will be getting their acetaldehyde. So this is interesting. Dry distillation is nothing but heating. Just आप heat कर रहे हो. Only calcium acetate आप लेंगे तो acetone मिल जाएगा. You will be getting acetone if you are using only calcium acetate. If you are using mixture, calcium formate and calcium acetate, you will be getting their aldehydes. And only calcium formate if you are using, you will be getting their formaldehyde. This is also one very important point that is to be noted. यहाँ नीचे आप देख सकते हो from acetylene. Only acetylene, that is CH triple bond CH you have to take when you are adding water in the presence of mercuric sulfate and sulfuric acid. Then first of all, CH2 double bond CHOH, this compound is formed, which undergoes a change we call tautomerism to form aldehyde. And very interesting thing is only alkane. This is the only alkane which gives you aldehyde. Remaining alkanes, if you are using, for example, if you are using CH3C triple bond CH, it will be giving you ketone. So aldehyde अगर आपको चाहिए तो you have to go with only acetylene. अगर आप propanol ऐसे नहीं, you cannot prepare propanol type of things by this reaction. You will be getting their propanol. Okay, this is the only aldehyde that can be prepared from this method, that is mercuric sulfate and sulfuric acid. You can prepare only acetaldehyde, not propanol, very important. Then Rosenmund reduction. Rosenmund reduction is acid halide converted to aldehyde by using palladium barium sulfate in quinoline. This reagent is called a Lindlar's catalyst. We know where we use Lindlar's catalyst in class 11. Yes, alkanes can be reduced to alkenes. If you want to stop the reaction at alkenes, then we have to use Lindlar's catalyst, and here the same thing. Acid chlorides can be converted to acid. Partial reduction, you can say. Only this chlorine is replaced by hydrogen. Then hydrolysis of gem dihalides. Gem dihalides means one carbon is holding two halogens, CH3, CH, chlorine and chlorine. When you are going for hydrolysis, it gives you CH3, CHOH and OH. This one. One carbon with two OH groups is unstable. So from this one, water molecule is lost and you are getting there CH3CH. Aldehyde is formed. From your hydrogen, from your OH, if you remove, you'll be getting there aldehydes. So geminal dihalides you can use for the preparation of aldehydes and ketones. Ketones, we'll discuss about ketones in ketones class. Then Walker's process. Walker's process is special. When ethylene is treated with PDCl2, CH2 double bond CH2 with PDCl2 in the presence of CuCl2, you will be getting there CH3CH. Very simple. From here, oxygen is joining here. That's all. These two chlorines, these two hydrogens, HCl, palladium is reduced. Palladium oxidation state is here +2. Here palladium oxidation state is 0. Palladium is reduced and ethylene is oxidized to acetaldehyde. Oxygen added means acetaldehyde. Very, very special reactions you need to remember for a long time. Walker's method, PDCl2. Walker's method means आपके mind में immediately PDCl2 आना चाहिए. PDCl2. From carboxylic acids, if you see, HCOOH and CH3COH, if when you are heating, this should be capital O, when you'll be getting there acetal. This is very similar to the dry distillation reaction. If you are using only HCOOH, formic acid, you will be getting there HCHO. If you are using a mixture of formic acid and acetic acid, you will be getting there acetaldehyde. MnO 300 degrees Celsius from carboxylic acids. This is, sorry, this spelling is wrong. Carboxylic acids. Okay, now I apologize for this spelling mistake. From carboxylic acids. From nitriles and esters. Nitrile is cyanide. When you are using with SnCl2, this reaction is called Stephen's reaction. In Stephen's reactions, first of all, imine is formed. RCH double bond NH is called imine. This imine further hydrolysis gives you aldehydes. Cyanide to aldehyde in the presence of SnCl2. Very, very, very important reaction. Very important. Rosenmund reaction and Stephen reduction both are very, very important. Cyanides converted to RCHO. Stephen's reaction. Alternatively, nitriles are selectively reduced by diisobutyl aluminum hydride. This is called a dibal H. Okay, now simply we write this as dibal H. Dibal H means diisobutyl aluminum hydride. Diisobutyl aluminum hydride. Diisobutyl aluminum hydride, if you are using, you can show like this, you will be getting their aldehydes. And the speciality of diisobutyl aluminum hydride is, its specialty is, it has no effect on this group. Double bond is unaffected, you can see. Double bond is not affected, only cyanide group is converted to CHO. That's why this is very special. Esters can also be converted to aldehydes by dibal H. Same reaction, this is an ester. Ester is converted to aldehydes. You can show like this for your easy purpose. I am showing you like this. Esters converted to aldehydes by dibal H. Dibal H is not a strong reducing agent. For mild reduction purpose we can use. Okay. So next is acetone. We will discuss about acetone in next class. Till that time, have a wonderful day. Practice करो. Don't forget. You have to practice, practice, practice. इसके बारे में questions, exercises, एक अच्छा सा असाइनमेंट जैसे लेके एवरी बिट हम डिस्कस करते जाएंगे. ओके, डन.